Hi folks, this is Steve here doing another quick video on FreeCAD 1.0 for amateurs. First of all, I want to apologize. I'll probably cough at times because my rhinitis is very bad today and I'm coughing like a who knows what. But I wanted to do a quick video on what is parametric modeling and why would you even use it. Well, parametric modeling is a way to quickly change the numerical values of various kinds of constraints without having to enter the sketcher or other operations. And you'll see what I mean as we go along. It's a way to quickly change the size of a design or a spatial relationship of a design that you have made. There are three basic ways to parametrically alter your sketches and alter your designs. And that's with a spreadsheet, which was the way that I originally learned. The varset, which has just come up, at least to my eyes, on FreeCAD 1.0. It's probably been there all along and I just didn't know it. And the third is the dynamic data workbench. I won't use the dynamic data workbench because it's a separate workbench, which I don't have, and these other two ways accomplish what I need to accomplish. But because the varset is embedded into 1.0 in the toolbar, we're going to use the varset function to show you how to be able to rapidly change elements of your sketches and your designs. Well, the question really is why bother? And so here is an example of where I would use and where I did use parametric modeling. If you're wondering what this is an end plug which fits on the end of a saxophone. The tenon fits inside the neck. The top sits on top of the neck so it doesn't fall down the saxophone neck. And my buddy, Randy at Axe Repair Music, wanted me to make a bunch to fit in different saxophones. So I've made this as a parametric model. Well, why? Because different saxophones have a different size tenon, a different size top, different lengths, different heights. And I wanted to be able to change these things quickly so I could 3D print him a new top or a new plug. Okay, well, let's go ahead and get started with that. Okay, so let's start in the part design workbench. Let's go ahead and start by creating a part. Let's rename that body to be the tenon so we keep ourselves straight. And under the tenon, let's go ahead and create a sketch. In the XY plane, let's grab, we're going to make a tenon, a circle. So create a circle by its center, basically now holding the axis to create a concentric point constraint on the axis origins. And let's make this 24.5 millimeters. By the way, in FreeCAD 1.0, I've simply released the mouse. I've not clicked, and I can just type in 24.5. Hit enter, and now we have a fully constrained sketch. Let's go ahead and close the sketch, and let's pad it. And let's call the pad 20 millimeters. Okay? So now we have the tenon. Well, now let's add a second part called the top. Rename it to top so we know what we're doing. Make sure it's the active body, and it is. By the way, that's right-clicking to see it's toggled. Create a sketch there. Create it also in the XY plane. Go ahead over here to view section, up here, right, over to the side, so we can see through to the axis hairs. Create another circle. Make a concentric constraint on the intersection of the axes. And let's go ahead then, use the dimensioning tool. Click on it, and let's call it, let's say 27 millimeters. Okay? We have a fully constrained sketch for the top. And now we can pad the top. Oh, and let's just call that 15 millimeters for now. Okay, so now we have a tenon and we have a top. Now we're going to have to, reposition the top at some point, but you'll see when we get to the varsets how I'm going to do that. Well, now we started this video because we want to be able to change rather quickly the tenon diameters and the top diameters. And as I explained initially, we're going to use the varset function. Well, up here at the top, at least on my computer, you'll find it somewhere. You'll see the pair of brackets, create a variable set. So let's click on that. And when you click on that, you'll see over here in the model section, we now have a varset in our tree. But when you click on it, you now have to add a property. This is where we define those elements that we're going to change as we need them. So let's go ahead and call this tenon diameter, because that's what it is. Hit tab to go to base. Use base is fine. The type is the property distance because it is a distance and it works best that way. Tab again to the value. And let's just make that 24.5 for now, like we did. Okay, hit enter. And now, if we go over to our tree and click varset, we can see that tenon diameter has been added under varset. Okay, now we want to add a tenon height. So let's double click on varset over here on the tree, and we get to add another property, tenon height. Okay? Tab through to get to the value, and let's just call it 20 for now. Click OK or hit enter, and now you can see tenon height has showed up. Okay? Now, once we've created the variables and their names, we have to assign those variables to the elements of the design which we wish those to reference. So the tenon diameter, of course, we want to reference to the tenon. So let's go ahead and make the tenon the active body by double clicking on it. Find the sketch under pad, click the sketch, double click the sketch, go over to the constraint, the 24.5, this is the diameter, double click on it, and you can see, the insert diameter. Well, off here to the side, this little blue guy right there is the expression editor. And you can get that by either clicking on that button or pressing the equal sign. This is where we can enter some sort of expression, arithmetic or otherwise, that will change this constraint. So let's click on that little blue guy to enter an expression. And now we're in the expression editor. Using varset, let's go ahead and type varset, and you'll see that it shows up pretty quickly in the drop down. I'm using the down arrow. I will select the varset, and now it lets me select in that varset which of those elements or which one of those values I want the varset to control. And in this case, it's the tenon diameter, right? So we're going to click on that and I'll hit enter. Hit enter again or click OK. And now this diameter is tied to that varset parameter. Click OK to get out. Okay. Now the next thing we want to do is we want to assign the tenon height to the pad, right? Because after all, that's what it is. So we double click on the pad. Once again, we got a little blue guy over here in the corner. Enter an expression. Type in varset. Down arrows, select tenon height. Select. Click OK. Click OK. So now we go here to varset. We have assigned the tenon height to the pad. So we should, if we double click or click on this and change it to, let's say, 24, it should get taller, and it does. We should be able to click on the tenon diameter, make it smaller, like by typing in 22, and it should get smaller, and it does. Okay, so now we can change the diameter of the tenon and the height of the tenon very quickly by clicking on varset and making those changes. Well, now what about the top? Well, for the purposes now, let's talk about the top. Well, the top is going to have a height, right? And it's going to have a diameter. But let's say that we don't feel the need to specifically measure the top. To sit comfortably on the saxophone, maybe we only want the top to be 3 millimeters in diameter larger than the tenon. How do we do that? Well, let's go back and double click on varset to give ourselves a new property. And let's call that top diameter. Okay? I'm going to tab through the different things till we get to the value. Now you'll notice, look, there's a blue dot in the value. So we can enter an arithmetic expression inside of the varset. So let's do that. Let's click that. And now I've decided that I want that it's fine if the top is just 3 millimeters larger in diameter than the tenon. Well, we're in the expression editor. So I'm going to enter varset, arrows down, click, tenon diameter, return. But I'm going to add plus 3 millimeters. See what I've done? In the expression editor, varset tenon diameter, 3 millimeters, click OK. Now let's go back to the top and see if this works, because we have to remember now we have to assign the varset to the sketch. So here we are in the sketch of the top. I'm going to double click on the constraint right here. Click the expression editor, varset, down arrow, select top diameter. Okay? Click and then click OK. And then click OK. So close. So now we should, I'm going to click on the varset in the tree. I should be able to simply change. So you see it's blue? That means that we're not going to change it directly. So if we want the top diameter to always be 3 millimeters more than the tenon diameter, we should see this get bigger as that gets bigger. So let's go ahead and make this 24.5. Okay, hit enter. See, they both got bigger. So now we've arithmetically tied the top of the top to be just 3 millimeters larger than the tenon. Okay, so now we do now have to add the top height. On a saxophone plug, the top height has no relationship to the height of the tenon, so we're going to have to enter that separately. So let's make, I double clicked on varset, name top height, tab, 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 just make it 20 for now, click OK. Now remember the top, the height of the top is the pad, the top's pad. Double click on the pad, hit the expression editor, type in varset, down arrows, varset, top height, click OK. Okay? So let's go ahead and see if it all works. So let's make the top height, let's say make it 15. And then the top here should get smaller. And it does. Okay, well, now we've got these two concentric discs, if you will, sitting in a relationship that doesn't really make sense. Sure, you could simply grab the top and move it using any one of a number of ways, including placement. But you want to actually tie the top to the top of the tenon. Now, those of you who have done this a lot could say, well, the best way to have done that was not to create a separate body, but essentially to create a sketch on top of the tenon face. And that's true, except remember, in the picture that I showed you, we're going to be doing other sorts of manipulations with the top and the bottom, and it's best to have them as separate bodies. So now, using varset, how do we tie the top to the top of the tenon? Okay, well, let's go ahead and click on the top. Let's make it the active body. And as you can see, as will always be true, we're going to get our data tab, which has various and sundry elements, including placement. So let's click on the downward arrow for placement. Let's click on the downward arrow for position. And let's now ask ourselves, how do we place the top on top of the tenon? Well, the answer there is to make its displacement in the Z orientation, right, the Z direction, Z, to be the same as the height of the tenon. So, and as you know, you can simply move it up by clicking, but look, in the position section, you've got an expression editor. Huh, well, let's enter an expression. Varset, and let's make it always be at the top of the tenon. So let's select tenon height because of where we want this to sit in the Z direction. Now this works because we designed this to sit flat on an XY plane. So the original design was placing everything reference to the XY plane, that is, with the Z function, the Z being 0. So let's go ahead and click tenon height. Okay. Look what it did. It now moved it to the top of the tenon. So let's say we want to make the tenon height to be 20. We're going to shorten the tenon height. Make it 20. Look, it drops. So now we can alter this plug by just simply clicking on the varset and changing those values in white, and we can completely change this plug. Well, let's double check ourselves real quick. Mail here, front, okay. According to the varset, the total height of this plug should be 20 plus 15, right? Tenon height's 20, top height's 15. So that should be 25. Well, let's go and grab ourselves a measurement. Okay? That's a new measurement tool, by the way. Click there. Click there. Look at that, magic. 35 millimeters. So our model works. Reset, close. All right, folks. Well, that's all I wanted to show you today. If you're interested in showing you the remainder of the problems that I faced with respect to designing the other, well, not really problems, let me know, and I can show you how to do the ribs using polar transformations and even the lettering. Okay, folks, I think that's all I wanted to talk about today. Thanks. Bye.